All right, so this is the last one that I'm going to model from Station 1 just because it is one of the more challenging ones. So this question is asking about formula units, and you might be thinking, what? There's no formula units on here. But remember, particles also includes atoms, molecules, and formula units. So you start off with 100 grams of that. So you have to go from grams all the way to particles or formula units. But if you notice, there's no conversion that actually does that directly. So you're going to have to do more than one step here. So you're probably going to have to go from grams to moles, and the only way that you can do that is through the molar mass because of grams per mole here, unit of molar mass. You're probably going to have to use this one, and then you're probably going to have to use this conversion. So let's go on and find the molar mass of potassium oxide. So potassium is K. It has a charge of +1 because it is in group 1. Oxide refers to oxygen, and oxygen has a charge of 2- because it is in group 6A, and all of those have a charge of 2-. So to figure this out, to figure out the actual compound, you can either go up and straight say, all right, in my final compound, I'm going to have potassium and I'm going to have oxygen, and I am just going to trade the charges to equal the subscripts. So this one's going to be a 2, and this one over here is going to be a 1. And then you'd figure out your compound. So your compound is actually K2O. You could do that, or you could see that to balance out a 2- charge, you need 2 positive charges, so that means 2 potassium atoms and 1 oxygen. Same reasoning, you get to the same answer. So the molar mass of this, you have 2 potassium atoms, so 1 potassium atom is 39.098, and you're going to multiply that by 2, because there's 2 of them. And you're going to add 1 oxygen atom, which is 15.999, and that is equal to 94.195 grams per mole because we're talking about molar mass. All right, so now we have grams here, we have our molar mass, we can get rid of grams because we don't want grams, we want formula units. So there are 94.195 grams in 1 mole. Alright, so now we see that our grams cancel out and we are left with the moles. But we still don't want moles, we want formula units. So this is where that second conversion comes in, where we have to use Avogadro's number. So we have moles at the top. I don't want moles, so I'm going to put moles at the bottom. Moles at the bottom. 1 mole up here is equal to 6.02 times 10 to the 23rd particles. So 6.02, I wasn't ready for this one, guys, times 10 to the 23rd particles. I'm just going to say P for short. So now I see that my moles cancel out. So my grams canceled out, my moles canceled out, and I'm left with particles, which is what I wanted. So now I just have to do the math. So 100 times 1 is just 100 times 6.02 times 10 to the 23rd, and then all of that divided by 94.195, and this is equal to a total of 6.39 times 10 to the 23rd formula units. I'm not going to say formula units. This should have been formula units. If you caught that, good for you. And that's it.